Hello everyone, thank you for tuning in again. This is Mr. Bohorquez here with Number Systems Lesson 3 for the week of April 20th through April 24th. This video's lesson objective will be the following. We will be able to correctly find the sum and difference of positive and negative fractions by finding a common denominator. You'll see a couple of those underlined. Sum, we should remember that means when we're adding two things. Difference, that means when we're subtracting two things. Now, a question that we want to be able to answer by the end of this video is, what do we need to do in order to add and subtract fractions? Just a brief summary of our last video. We talked about how to multiply or find the product and how to divide or find the quotient of integers. Remember, integers consist of positive and negative numbers and also include 0. The rules we learned for multiplying and dividing integers or positive and negative numbers is that when you multiply two positives, a positive times a positive gives you a positive product. A negative times a negative also gives you a positive product. However, if you were to multiply a positive times a negative, you get a negative product. A negative times a positive, you'd also get a negative product. So basically here, an easy trick to remember is the same sign ends up in a positive, and when you have different signs, or one's positive, one's negative, vice versa, you get a negative answer. And that these rules also apply for division when you're finding the quotient. Before we really dive into how to add and subtract fractions, let's do a bit of review on fractions themselves and how they relate to number systems. Remember, fraction is a number set that's usually denoted by this funny looking Q here, and these are also known as rational numbers. They're a subset of integers. That means they're smaller than integers. When you see a fraction, there's two numbers. There's a number on top, and this number is called the numerator. And there's a number on bottom, and this number is called the denominator. You can see in the example here, we have 1 in the numerator and 2 in the denominator. We can say this is 1 over 2, or simply 1/2. As mentioned, fractions can be smaller than integers. On our number line, we see here our integers of -1, 0, 1, and 2. Notice these are whole numbers that are including 0 and also negative. Rational numbers, however, can be smaller than that. For instance, notice how we have between 0 and 1, halfway between them is 1 over 2, or half. In between 1 and 2, we have 1.5. And over here on the negative side of the number line, between 0 and -1, we have -1/2. Another way we can look at fractions is to consider them parts to the whole. What this means is that we have as the numerator and denominator here, the numerator represents the parts, or how many pieces there are, while the denominator represents, well, how many whole pieces there are. In the case of this pizza, we can see here that there are 1, 2, 3, 4, 5, 6, 7, 8 pieces. That represents the whole amount. If you wanted to say, have a slice of pizza, you take one away, and you're left with 1, 2, 3, 4, 5, 6, 7. 7 pieces of pizza out of the entire 8 that were there in the beginning. Parts to the whole. The key detail when adding and subtracting fractions is that you must find the common denominator. A common denominator between two fractions is when they have the same denominator for both fractions. The reason we need to find the common denominator is to make sure that when adding two fractions, we have the same amount to the whole. In the case of saying, well, you having 2 pizzas that are cut up into different amount of pieces, how could you add them together properly? First, you would have to make sure that they are into the same amount of pieces. that they are cut up into. That way, you can now determine from their whole pieces that are the same, how much is there when you add them together. The best way you can find a common denominator is by finding something called the lowest common multiple, also known as the least common multiple, and that'll be denoted as LCM. Or it can be called the least common divisor, or the LCD. Now, the LCM or LCD is when you find the smallest number that two numbers can go into. In the case of 2 and 3, well, the smallest number that both of these numbers can go into is 6, because 6 divided by 2 is 3, and 3 divided by 2 is 6. In the case of the numbers 4 and 10, the LCM or LCD here we see is 20, because 20 divided by 10 is 2, and 20 divided by 4 is 10. 20 is the smallest number that both of these numbers can go into. Let's take a problem such as this. We have 3 over 12, or 3 twelfths, plus 4 over 6, or 4 sixths. And we want to know what's going to be the resulting sum. What's that fraction going to look like? The first thing to notice is that the denominator 12 is not the same as the denominator 6. So we must find a common denominator. Consider what numbers do 12 and 6 go into evenly. Now, feel free to use your calculator or even a multiplication table to help you out on this one. But you may notice that if you were to double 6, say multiply 6 by 2, well, that would give us a 12 on the bottom there. One thing to remember when doing this is that if you were to multiply something to this denominator, you have to multiply that same number to its very own numerator. We'll discuss more about this in just a second. 4 times 2 is 8. Now, since we multiply both the numerator and the denominator by 2, we have scaled this fraction. We made it bigger, but these are the same fraction. They're what we call equivalent fractions. Now, we have a denominator that matches the denominator that we want to see. We keep the first fraction the same. And now, since we have a common denominator, all we have to do is just add across. For the numerator, that is. Our denominator, the whole pieces, stay the same, because that's how many total pieces we want to know we have, or the whole pieces. 3 plus 8 becomes 11. So, our answer now is 11 over 12, or 11 twelfths. Again, the first thing we want to do is find a common denominator. 12 and 6 share a common multiple, a least common multiple, of, well, 12, because 6 times 2 is 12. Whatever we do to the bottom, or the denominator here, multiplying by 2, we have to do the same to the top, the numerator. And that gave us 8. Since we then had a common denominator, we could add across these fractions. So that would be 3 plus 8 is 11. But we want to keep our denominator the same, because this represents the total amount of pieces. I want to go back to how we multiplied two numbers, a number in the numerator and the number in the denominator, and got another fraction and said it was okay. When doing this, we create something that's called an equivalent fraction. And what equivalent fractions are is that they represent the same amount. In the case of these two birthday cakes, notice how if I take away one out of the two pieces of this birthday cake, and if I take away 2 out of the 4 pieces of this birthday cake, they represent the same amount of birthday cake. It's just that this one has 2 smaller slices and this one has 1 larger slice. Well, for that very same reason, if I were to multiply the top and bottom by the lowest common multiple. In this case, let's see, 2 and 4, well, that'd be 4 because 2 times 2 is 4. And if I did the same to the top number, the numerator here, you'll see that they equal the same amount. They're equivalent fractions. By doing this, we're able to find a common denominator with a lot more ease without changing the actual amounts themselves because they represent equivalent fractions or the same amount. Something to keep in mind is that whole numbers and integers can be fractions too. So if you ever see a whole number or an integer, like this one here, -3, all you have to do to turn this into a fraction is put a line underneath the 3 and a 1 in the denominator. When subtracting fractions, we also need to find the LCM, or lowest or least common multiple. In the case here, we have 6 over 7, or 6/7, minus 2 over 14, or 2/14. Notice how the denominators are not the same, but we can find a common denominator by considering the lowest common multiple. Well, I do believe if you multiply 7 by 2, you will get 14. So let's do just that. Let's multiply this bottom denominator here by 2. Remember, whatever you do to the bottom denominator, you have to do the top one as well. So let's multiply that top one by 2 as well. That gives us a new equivalent fraction of, let's see, 6 times 2 is 12. And 7 times 2 is 14, just like we wanted. Now, we have a 14 in the denominator here. There's a 14 in the denominator here. We have common denominators. And we may subtract them just like how we did when we added them. We'll say 12 minus 2, and that's going to be 10. And since these are 14 whole pieces, we don't want to subtract that from each other, so we'll just leave that as 14. Another thing to consider about adding and subtracting fractions is that they obey the rule of adding and subtracting positive and negative numbers. In the example here, we have a -4 over 11 plus a positive 7 over 22. Now, to make this problem a little bit easier for us, we can actually consider the negative to be here by the 4. That way when we go to do our math, it makes more sense to us. It's the same thing as having the negative out over here, but when we go to add these fractions, it'll just be easier for us to consider the negative right here in the numerator for -4 over 11 plus 7 over 22. Well, we want to find a common denominator, and we could do that by finding the least common multiple. Well, we see here 11 and 22. I do believe if you multiply 11 by 2, you get 22. How lucky for us, a lot of these are multiplied by 2. And we want to do the same here and multiply the numerator by 2 as well, just to make sure that we're keeping this equivalent. -4 times +2, well, considering our last few videos, 4 times 2 is 8, and a negative times a positive is a negative, so that results in a -8 over 22. 11 times 2 is exactly what we wanted. Now we're going to add that to 7, +7 over 22. Well, luckily for us, since the denominator stays the same, there's no need to do any math there. But now we have to consider -8 plus 7. And if my math is correct, that should result in a -1. Now you can leave the negative on top like that. You can put it in front like this, either or. But your answer is going to have a negative because, well, there are more negative pieces to positive pieces. So the same rules apply when we're adding and subtracting our positive and negative integers. Now, I want to do an example like this, which has several different components to it. Things we learned in this video as well as previous videos, just so we can build on all these skills that we're acquiring. It's asking us to simplify the following. We have a whole 3 minus a -2 over 3, or 2/3. And we're trying to find what that fraction is going to be, what the difference of the two are. One thing to remember is that we could put a 1 in the denominator here, and that becomes a fraction. Now we have to consider what are the common denominators, or what's a least common multiple of 1 and 3. Well, fortunately for us, if you multiply 1 by, or anything by 1, you get that number. So if we multiply the bottom by 3, we should have a 3 in the denominator. Remember, you have to multiply the numerator by 3 as well. That way to keep these equivalent. We have 3 times 3, which will give us 9. And 1 times 3, which is a 3 in the denominator. Now we're going to subtract. Let's see, we have negative 2. And that's going to be over 3. So we have that common denominator that we're looking for. Well, fortunately for us, since we're keeping the same amount of whole pieces, a whole, I should say, whole, it's a whole amount, we're going to keep that 3 in the denominator, since we already have that common denominator. Now we have to consider, what is 9 minus negative 2? If you recall from the previous videos, if we want to subtract 2, we have to consider this to be negative is the opposite. So realistically, this is going to be 9 plus 2, because these kind of cancel to make a positive. So 9 plus 2 becomes 11. And that fraction is 11 thirds, or 11 over 3. If you want, you could simplify this further by making a smaller fraction, or perhaps a mixed number, I should say, but that's for another lesson video. This answer will suffice. I want us to practice a little bit with adding and subtracting fractions with a bit of a word problem here. Now, this word problem is so we can use our annotating or our note-taking skills in order to help us find that important information throughout this word problem that's really going to help us figure out, well, what it's asking us and what it's telling us, and how we're going to find that answer. It says, yesterday it snowed 2/10 of an inch, and today it snowed 1/5 of an inch more. How many total inches did it snow? What I'd like you guys to do is pause the video and consider this. I recommend writing it down, annotating, that means maybe circling numbers and putting a box around keywords and underlining the question. That way we can at least figure out what's this word problem telling us, and how can we use that to figure out what we should do. I hope you guys took a little bit of time to at least annotate it, and so I want to do that part right now. So at least we have those kind of skills that'll help us with future word problems to determine exactly what it is we're supposed to do mathematically. As I read this problem, I see yesterday it snowed, well, our first number, our fraction rather, is 2/10. So I'm going to circle that number so I can remember, of an inch. And today, so one was yesterday, one's today, it snowed 1/5 of an inch more. I feel like this more thing is really important. How many total inches did it snow? Well, I kind of want to underline that, because that's the question that it's asking us. It's asking us how many total inches did it snow? How much all together? Let's see. So total, I kind of want to put a box around that. That's kind of a keyword there. So considering what we just figured out, realistically, you can kind of eliminate a lot of this other stuff that seems a bit confusing. We see that we have 2/10 of an inch of snow, and then 1/5 of an inch of snow more. And it's asking us the total. If the question is the total, well, there's two key words here, more and total. And if you're thinking what I'm thinking, it sounds like we're going to have to combine something. What's the word more going to mean here? In the case of adding and subtracting fractions, I think that means we're going to add these two fractions. I believe that more refers to adding these two amounts, and total is the total sum, the total amount of snow that there was. That's how we find that key information that we're looking for. This problem is really asking us, what's 2/10 plus 1/5? And that is how we annotate. And we can use that information to go ahead and solve this problem. Well, let's see here. We want to have a common denominator. We have 2/10, 1/5, 1/5, 1/5, 2/10 and 1/5. Well, again, fortunately for us, 5 does go into 10. In fact, we can multiply 5 by, well, in this case again, 2, and multiply the numerator by 2. And that gives us something like, oh, let's see, 5 times 2 is 10, exactly what we wanted. 1 times 2 is 2. And right here on the first fraction, we still have 2/10 as well. Ooh, how interesting. I bet these are equivalent fractions. They're equal, but we didn't know it. Well, let's see. If we add them up, we simply have 2 plus 2, which is 4. And the denominator stays the same, which is 10. In total, it snowed 4/10 of an inch. And that is our answer. Okay, as we wrap this video up, there are a couple of key ideas that I really want you guys to be able to walk away with, and I think it will help you a lot when trying to add and subtract fractions. First, we want to remember that fractions, when we're talking about number systems, they're also called rational numbers. You'll see that a lot, especially later on. Now, they also represent pieces or parts to the whole, and specifically that top number of pieces, we call that the numerator, and the bottom number, the denominator. And a way you could think of that is like saying you have half a cup of sugar, or 1 out of 2 cups of sugar, or here 1 out of 6 candies. So perhaps you had 6 of them and 5 are gone. Now you only have 1. Okay, and so we also want to know, when adding and subtracting our fractions, we want to find the common denominator. That's when the denominator on both fractions are the same, by using the least common multiple or lowest common multiple, or the LCM, or sometimes you'll see LCD for least common divisor. And remember, when you're adding and subtracting fractions, that the same rules of positive and negative numbers, or integers I should say, apply to adding and subtracting fractions. So that means make sure that when you're subtracting a negative, it turns into a positive, and so on and so forth, okay? Okay, everyone, I want to thank you for taking the time for watching our number systems video 3 on adding and subtracting fractions. Just to let you know, coming up next for the video is going to be multiplying and dividing fractions. So just like how we went from adding and subtracting integers to multiplying and dividing integers, we're going to go from adding and subtracting fractions to multiplying and dividing fractions. And that's going to be the majority of what we can expect in these number system work packets, okay? After that, we're going to have an additional week where we're going to review a couple of things, maybe go over some more word problems, and that should do it for number systems. So I look forward to having you guys tune in next time, and I want to thank you again, and keep practicing your math.